Hello, everybody. Again, my name is Vladimir. I'm sorry in advance for my English, but it is definitely better than my French. My native language is Russian. I'm working for a Russian company called ElcomSoft. Probably you know it. What we're doing for last 20 years, we're doing the password cracking, password recovery, and data decryption. And about 2 years ago or so, we decided to go deep inside the iPhone encryption, iPhone passcodes, and everything. Our company is rather small, about 20 people only, but we all do love the iPhones. And you know, if you love something, you're going to go deep inside of that to understand how it works. Why we decided to accept just for just an interested? There is a lot of iOS devices now on the market, and now available for 5 years. There is a lot of models working on iOS, iPhones, iPads, and iPods. According to the data released during the last Apple Worldwide Developers Conference, there is now over 600 million devices. And this is not just the iPhone, just the phone or the player. Many people nowadays using their iPhones and iPads as a business instrument, working with the mails, working with the internet, working in social networks. And there is quite a lot of very interesting and sometimes very critical information in those devices. And besides, there is much more and more corporate installations of the iPads. They are now even allowed to be used by pilots on the planes. And I should say that iOS data protection implemented in the iPhones is extremely good. The first level of protection is the device passcode. And for some models, I will talk a bit about that later, there is a workaround, not exactly a workaround, but you can still get much of the device information without knowing the passcode. For some newer devices, you cannot work around of that. And just bypassing the passcode is not enough, because the passcode itself is being used in the encryption of the data stored on the iPhone. And the second level is the disk encryption. The contents of all the data stored on the iPhone is also encrypted, using both the hardware keys, which are unique for every iPhone, and also the passcode. And also, there is the third level for storing the probably most critical information of the iPhone, the stored passwords. They're all stored in the keychain. This is something like a Windows registry or something like that, or about the same as the keychain in the macOS operating system. But it is additionally protected, not just with the hardware keys and the passcode key. What we can do to analyze the information stored in the iPhone? There are basically the three ways. First, there is a logical exposition. That's the simplest and probably the most convenient way. You just connect the iOS device to the iTunes, ask it to make the backup, and then use one of the third-party tools to analyze the contents of the backup. It stores all the call logs, messages, SMS, and iMessage, mail, pictures, videos, and everything. But that's actually not everything. You can get much more by performing the physical exposition and doing the exact bit-by-bit image of the iPhone memory. It is much harder to do. I'll say about just a couple of words about that a bit later. And there is the third way now, by analyzing the backup stored in the iCloud. For the logical exposition, just as I said, just click on the make backup in iTunes, The only problem might be that the device should be unlocked. So you have to enter the passcode first. And if your device is passcode protected, it just won't be able to be paired with a new computer. Of course, you can still create a backup on the old computer. And another problem is that the backup itself created by iTunes can be password protected. And the password protection with the iTunes backup is implemented really good and smart. The password itself is stored inside the iPhone. So if you have set an iTunes backup on one computer and then connect this iPhone to the other computer and ask to perform backup there, then the backup will be created with exactly the same password. And you won't be able to change that password without applying the old one. And as I already said, not all the information is stored in the iTunes backup. For the physical expedition, we have to run the code just in the iOS kernel. And to do that, there are basically two ways. For all devices, we can run the boot time exploit. And actually, this is about the same as jailbreak, and it is possible for old iPhones up to iPhone 4 inclusive, because there is a vulnerability in the boot ROM code. Or for newer devices, for example, for iPhone 4S and for iPad models 2 and 3, we can first perform the jailbreak, which is on operating system level, not on the boot level. And then we can load our own RAM disk into the iPhone and run our own unsigned code. If we do own the Apple keys to sign the code, that the software will be running on all the modern models, but obviously Apple will not give us the keys. And so for now, we cannot do anything with iPhone 5 and iPad 4. The iOS 4 passcode. There are 3 types of passcodes. By default, you're using the simple 4-digit passcode. Alternatively, you can switch the option to disable the simple passcode, and you will get the complex one, which may contain all the letters, small and capitals, and digits. And there is actually the third type, which is not listed in the iPhone settings. But if you will switch the simple passcode off, but enter the new code with only the digits, but not exactly the 4 digits, but either less or more, for example, 3 or 8, you will get the third type of the passcode, which contains digits only on the second screen, but can be much longer. Actually, I think by asking many friends and colleagues what type of the passcode they use, and most of the people use a simple 4-digit passcode. Simply because you have to unlock your iPhone every time you have to answer the call or to make some operation. It's really disturbing to enter the long passcode with capital and small characters and so on. But the problem with brute forcing the passcode, I'll go back. The problem with brute forcing the passcode is that the code to crack all possible passcodes can run only on the device, because it uses the hardware keys, and it cannot be done offline on a much more powerful computer. And the speed of cracking the passcode is very, very low. It's just about 5 or 6 passwords per second. So we can crack the simple passcode containing 4 digits only, but it is much more complex to crack longer and more complex passwords, probably only using dictionary attack. But if the password is longer, say 7 characters, small and caps, we won't be able to crack it. About the iCloud, it is now available for almost 2 years. It has been introduced starting with iOS version 5. And you got a 5 gigabyte storage on Apple service. Actually, not on Apple service, but the third-party service. But anyway, and you can pay some money and expand the storage up to 50 gigabytes. And according to the latest data, there is over 300 million iCloud users. How they use the iCloud exactly, there is no statistic. But probably most of the people using them for iCloud backups, that's first. And the second for storing the documents, mostly from the Apple applications. But of course, you also can store the notes and calendar information in the iCloud, and also use the Find My Phone services. Here are the iCloud services. You get the mail, you get all your address book there, the calendar events, notes, now reminders, Find My Phone information, and iWork documents. iWork documents is only pages. Keynote for presentation. Now I'm running also the Keynote presentation from my iPad, and I was editing it on the iPad and the next day on my computer because it is stored also in the iCloud. Yeah, you can first to work with iCloud, go just to the website icloud.com and access all information there. But then the other way is use the iCloud control panel, which is available for both Windows and macOS operating system. But there is not much to do with that in the right here. You can only see what information is synced with iCloud. You can get the photos from PhotoStream, and you can understand how much storage does it take. Why doing a cloud backup instead of the local one? That's a very good question. A lot of people take care about their privacy, and they don't trust the third-party services to store their data, and doing the backups only locally. But there is one big profit for using the iCloud backup for the iPhone. If you will be able for some time to make local backups, for example, when you are traveling, then the only way is to create the backup in the cloud. There was a story happened to me about a year ago. I was traveling and was sailing actually in Norway in the Northern Sea with my friend, and I have dropped my iPhone in the salty water, and it was totally corrupted. I wasn't able to repair it, but the next day I got the new iPhone and restored it to exactly the same state it was just a few hours before I lost it. Here is what happened to my iPhone. That's everything. That's when I arrived to the office. I tried to repair something, but I wasn't able to. But all my data was there. What is backed up in the iCloud? Basically, the same as in the iTunes local backup. So it's all your contacts, messages, data from application, in-application purchases, the call history, photos and photo stream, paired Bluetooth devices, and much more. So as I said, about the same as in a local backup. When iCloud backup is created, there are two ways. First, it can be done automatically when I connect your device to Wi-Fi network and also to the power source, and the device is in a locked state, so you're not actively working with it. And the second way is just to call the backup functions right from settings. Settings, iCloud, storage, backup now. The backup will be created immediately. And here is how to switch between local and iTunes backup. And just in iTunes, you select where to backup, to iCloud or to local computer. And there is also an option for setting the iCloud password. But even if you can set this password in with any settings, but it works only for local backups. And it's not applied to the backups made to iCloud. And another problem with iCloud backups, that they are working both backup and restore processes. they're working only through Wi-Fi, not by wire. And you can also see how much storage you have and how much your backups takes there. If you go to the control panel and switch to backup, you can see that all of your devices connected to your Apple ID and how much every backup takes. So how we have explored and analyzed the protocols. And then the title of my speech is saying that cracking Icloud protocol, it's actually just to make the good name. We haven't cracked anything. We haven't found vulnerabilities or so on. We have found just some interesting information about the security of the iCloud backups and how all the data is stored, but not exactly cracking. So how we did it? First, we have got the old iPhone 4 because it has the best untethered jailbreak. And then installed the OpenSSH tools and got the keychain. Keychain is stored in a single file from that iPhone. And then we have switched the options to delete everything from the iPhone and reset settings and reboot process started. Then we have set up iPhone to use the Wi-Fi network, which was our own, and we had the logging the proxy with a sniffer working there, and then we have replaced the keychain information, the encryption certificates used for encrypting all information transmitted between the iPhone and iCloud. We have encrypted them back, inserted in the keychain, and using the SSH, put the keychain back to the iPhone. And now we were able to sniff all the traffic that comes between the iPhone and the iCloud service. Here are some basic facts about the backup protocol. We don't know in advance where the data is stored. It is being stored actually, as we have found, on either on Amazon cloud services or in Microsoft services. The protocol is built. It is very similar to Google protocol buffers, very, very similar. And all files are being split into chunks. Chunks are just blocks of information. And all the data is stored in chunks in the iCloud, and also there is a file like a map with all the information, what chunks are related to what files. And also the groups of chunks are encrypted with their own individual encryption keys. So some chunks are encrypted with one key, and then some keys, some data with another key. Here is basically the structure of the data stored in the iCloud. There are files, there are chunks, there are chunk groups, and there are containers. It looks really complex, but with the functions available in the iCloud, we have retrieved and reversed it. It's a bit simpler to use. Here, for example, the first two queries. Very first one is to perform the authentication in the iCloud. We just start the HTTPS passing the Apple ID, and authorization type is basic, and the data, authorization data, is just encoded and concatenated Apple ID and the password. And what it returns back is the authentication token and the ID we can use in further queries. And below is the example of the query sent to perform the authentication in the cloud. Then there is a series of other queries, also with passing the authentication token, but it returns the new other one in back. It has the same name, but actually it is different. and then using that other second authentication token, we can get the list of backups available in the cloud, which are connected to this particular Apple ID. And also the next query, the last one in the list, is the get the encryption keys. There are a lot of encryption keys returns because, as I said, the backup is encrypted not as a single, the whole chunk of data, but all the chunks are encrypted individually. Now downloading files. Once we have got the list of backups and the encryption keys, there are also HTTP GET requests, and we pass the backup ID, get a file authentication token, which is also different from the previous one I told about. And then we have we were doing the HTTPS post query. It's also backup ID and with a command to get the files. And as a last step, we get the particular links to individual files, to the chunks. And if, for example, the file is being split into two chunks, one chunk may be stored in the Amazon cloud and have its own encryption keys, and the second chunk of the same file can be stored in the Microsoft cloud and encrypted with the other key. But once we have got all these links, here are how they look like. They're very long and complex with the data. You can see that in one parameter there is a time. It's iCloud authorization time, and once this time is once 1 hour is passed, there is a timeout there. You won't be able to get files, and you have to perform the secondary authentication. So here is a conclusion about the iCloud encryption. As I said, the data is stored on third-party storage providers, and it is encrypted, but the keys are stored along with the data. And obviously, Apple has access to this data, not only the files, but the encryption as well. Sometimes are additionally encrypted with a backup keyback. OTA means over the air, which is passed by Wi-Fi. And keychain files are encrypted as well. The only thing we cannot decrypt from the iCloud is the keychain. You remember I told you about the backup encryption with the local backups. And there is a very big difference between encrypted backups with a password and not encrypted backups. If you perform in iTunes the backup without supplying the password, then the keychain data in this backup is encrypted using the encryption key generated based on the hardware ID of this iPhone. What that means, that if you try to restore from this backup to the new device, you will lose all the data stored in the keychain because it simply won't be able to decrypt. And if you set the password to local iTunes backup, then the keychain data is encrypted using on the other encryption key, which is generated only from this password. And so this data will be accessible, and you can restore your device to the new backup. That's why I recommend everyone is to do the encrypted backups in iTunes. What data is stored in backup? In the keychain. That's basically these are passwords, certificates, passwords, and authentication token. So that these are passwords to Wi-Fi access points, password to all of your email accounts, Google, Exchange, or whatever. Passwords stored, the data cache stored in the browser in Safari fields, which may also contain the passwords or credit card data or whatever. And a lot of other things like authentication tokens for Twitter, Facebook, and social networks. And in the iCloud, A backup is stored is about the same way as in local, not password-protected backup. So once we retrieve the data from the iCloud, what we cannot decrypt is the keychain data, because it is encrypted on the key number 835. Someone which were in the business of jailbreaking may know what is that. And we can get it only if we have the access to physical device. So a brief summary about the encryption. We cannot do anything to further encrypt the data stored in the iCloud. We cannot supply our own encryption keys or passwords or whatever. And again, iCloud stored in Microsoft and Amazon. Apple has the encryption keys and can get all your data from the storage except just the keychain data. And if Apple stores the 835 keys, we don't know that, and we cannot be sure, then he can also access your keychain data. Probably there is a chance that they do store this encryption key for all their devices to be able to decrypt the data once they have requests for from law enforcement, from the government, from police, FBI, or some special forces or whoever. What we have done is we have made a software which is able to download backups from the iCloud and convert it into the same form as the iTunes use. And for many people, it is very convenient to get this data from the iCloud. For example, when you don't have Wi-Fi or only wired connection, or in a lot of other situations. But last March, about three months ago, at about the same time when the Apple introduced the two-factor authentication to access your Apple ID data, I have found that everything has stopped working. And we were scared a little bit, and we thought that two-factor authentication also works for iCloud backups. But we have found that there are only bits, very, very small changes in the protocol. So once again, we made a jailbreak. We installed OpenSSH tools. We have replaced the keyback, and we sniffered all the traffic between the iPhone and iCloud. And we have found we just have to add a few lines of the code to the authentication request, and change the protocol version and add a couple of lines. That's it. Now about Find My Phone service. It's actually a very good one, and I'm using it myself. And sometimes it really helps. Once this service is enabled, you can always log on to iCloud.com and to see where all of your devices are located. You can see that this is for my personal account, actually. You see the Vladimir's iPad, iPhone, and so on. Actually, I have about 15 devices here, because many times I have lost my phone and iPad, and all those devices are still there. And currently, it shows the location of the iPhone at my home. What is being done when the service is working? The Apple service is sending the push notification to the device, and the device is turning on the GPS, found its location, and send it back to the Apple service. And this data stored on Apple service for some time. To be honest, I don't remember exactly how long is it stored. It is either 3 hours or 6 hours, and then this data is wiped. But of course, to be able to use this service, you have to enable the location services on your iPhone, and the iPhone should be accessible through 3G or Wi-Fi. Analyzing the Find My Phone protocol was much simpler than analyzing the backup protocol, because we have just installed the sniffer and was reading the requests which are being done when accessing the iCloud.com website. It is similar, but not the same authentication as for iPhone backups. First, we are sending the validate request. After validate and confirmation that we can access the backup. We perform the login, supplying the Apple ID and password. And the third command is to get the list of all the devices which are connected to this Apple ID. And for every of those devices, we get the data back, whether the location services and Find My Phone service is enabled, and if yes, what is the location, the time it has been last seen, and so on. Here is the output from console application, which outputs the names and IDs of all the devices, and whether the location is enabled or not, and exact location, and also whether it received through 3G or Wi-Fi, and the time it has been found. Now about Icloud documents, the third part. Once you log on to iCloud.com and switch to iWork, you can see all your documents you are storing in iCloud, but only from the keynote, pages, and numbers. And you can do that from also from the device, from the iPhone or iPad, and not only from the website. And interestingly, that for the documents in all these three file formats, once you click the download, you have three choices: to download in the original Apple format, to download in PDF, and to download in the file format compatible with Microsoft Office. Or you can also use the iCloud control panel and see all your documents are listed there, and you can delete them from here. Just you cannot download from here or cannot upload to there. So sniffing the protocol to get the documents was also not a very complex task. First, we send the authentication request with the Apple ID and password to get the authentication token. And it is also similar to Find My Phone and to backup protocol, but slightly different. And in return, we get the token and IDs. And then we send another request to get account settings, and then request to get the file list. And for every file, we get its name, the ID, the parent folder ID, because the files can be organized in the folders. The time when the document has been last changed, the checksum and the access right. And to download the given file, we're just providing the file ID, checksum, and the other parameter called alias map. And also we have to send another authorization request, and in return we receive also the file chunks. It is actually the similar as an iPhone backups. Also, every file is split into chunks. Here is about packages. As I said, the Apple iWork documents can be downloaded in one of three forms: in native format, in Microsoft format, and in PDF. And we have found that even so you work with iWork application on, for example, iPad or on your macOS computer, and you think that you're working with pages, so okay, no documents. In the iCloud, it is stored in some interesting internal file format. There is something like a database, an XML file with data itself. And all the files, which are media files, like as pictures and videos and so on, are stored separately in its original form in JPEG, AVI containers, GIFs, or PNG files, or whatever. And also there is a playlist file, which is also an XML, which stores the structure of how these files are organized. And to retrieve those files, the packages, not just the pure native files, there is another set of commands to validate, login, export in one of the given file formats. Then, after some time, we can send the request to check the status of the conversion. And once we have got the status that the file has been converted, we download the converted file. Oh, okay. I need maybe a little bit more. Okay. I will try to. Faster. Here is how to use this, except the way the Apple is doing that. For backups in iCloud, we can perform the near real-time acquisition of the data stored there. Recently we have found a way to download not the complete backup, which can be extremely large, especially if you have a lot of pictures here there, for example. But we can send just a few simple requests to extract only the most important data, which is the SMS messages, address book, iMessage, recent calls, call logs, and maybe something other like Skype logs, Facebook log, or Twitter, or whatever. And also, we can work with it with this backup without having an actual device in hands. For Find My iPhone, that could be an interesting application to track all the time the location of some device, or maybe of two devices on the map, and can receive a notification when the person is entered some area or left some area, and so on. The only problem is that if you'll send the request to get the location all the time, the battery, the iPhone battery will be decreasing very fast because it's always detect the location. And also for documents in the iCloud, to have more convenient work with them, not only as Apple advised, but to be able to work with our own data there. About Apple two-factor authentication introduced recently, you have to have the trusted device, and to enter the Apple website, you will have to enter the code which is being sent by Apple push notification to the trusted device. But as I already said, this two-factor authentication doesn't protect the backups, documents, and Find My Phone data. Here are the limitations. It protects only access to the Apple ID and purchases and so on, but doesn't protect the iCloud. In iCloud, iOS 7, introduced just about a month ago, we have got some interesting changes. That is how you can store all your keychain, not only locally, but in the cloud, and sync it between devices. It's pretty smart and convenient to use, and I'm going to use it too. And it is, I should say that this time it has been made really secure. You will be able to access the iCloud keychain data from the other computer or the device until you have received the notification with the iCloud security code. And here how it looks like, the keychain. In the keychain utility in macOS, you have a new category called iCloud, and it is basically contains all the stored data for website passwords, internet passwords, and so on. And here is how it looks like on the iPhone or iPod Touch. And here is how to enter the verification code on the device running the running the iOS 7. There is one code which contains four digits only, and there is also the special recovery key which may contain not only digits but also letters. It has been done for the cases when you completely lost all the devices which may accept which may send the security code, and so you have to have at least one way to retrieve your data. And one other interesting thing of iOS 7 is that to disable location services, you have to enter ID and the password. It's a very smart idea and good additional protection. That's it. That's a final slide. I should say that basically the security in an Apple product is really good, but as always you have to select between the security, privacy and convenience, and usually you can get only 2 of the 3 and you cannot get all of that. For iCloud, I would still recommend everyone to use it, but you have to understand the security risk and that some third party, Apple, Microsoft, Amazon can access your data. And you probably heard about the last scandal about the PRISM system and the number of requests to reveal the customer data. It's not clear what exact data has been revealed by Apple, but I think that's the data stored in the iCloud. And for Apple, the numbers are not very high, but still, that's between 4,000 and 5,000. What we do expect from the Apple is to implement the better two-factor authentication and for additional protection of your backup data and for iCloud documents. And finally, of course, we have a lot of work ahead to understand how the data of other third-party applications is stored in the iCloud, for example, and also to work with photo streams and so on. Oh, that was a last, sorry. One more thing. That's about Windows Phone backups. We have started to receive more requests to analyze Windows Phone backups as well. It is not as smart as the iPhone backups. First of all, not everything is stored, only the basic data, the SMS, messages, address book, and so on, and pictures and media. But not the, for example, application settings. But the good news are that there is a standard way Microsoft leaves the car, which allows to get at least some of this data from the cloud without reversing, but not everything. So what we are now doing is that we are analyzing the way how to retrieve the complete Windows Phone backup from the iCloud and to make our own API to work with it. So thank you very much. Now questions.
Thank you for this talk. Any question? Who has? I can't believe.
When there are no questions, either everybody understands everything or nobody understands nothing.
No question can mean 2 things. Either it was very good or it was terrible. So let's have, I'm sure people here have questions about iCloud protocols. What do you think about, Vladimir, what do you think about iCloud protocols? Are they safe enough? Are they, what about our privacy, for example?
Yes, safe enough, but as I said, I want to see the better two-factor authentication, first of all. And second, I would like to be able to encrypt the data stored in the iCloud with my own encryption keys or passwords, so I have to be sure that nobody except me knowing this keys or this data can access it. Now that's not the case. And everybody with a just knowledge of your Apple ID and password, and obviously Apple knows that, can access your data and read it. I don't feel very convenient about that.
Okay, and what about documentation about iCloud protocols? Would you recommend any source of documentation?
There is no documentation at all. I know a few companies which are doing something with iCloud documents to be able to send the documents to the iCloud and to retrieve them from there. I also want Apple to release some more API to work with the iCloud documents, not only from the iPhone or from the iPad, but also for macOS and for Windows. I think that will be much profit from that for all of them, not just for Apple, for all the customers.
Okay. Nobody has any question? Okay, so we can thank Vladimir for his talk. Thank you very much.